Good morning. Today we're going to talk about ratios and how you can represent a relationship between two quantities. This is from your Big Ideas Math sections 5.1, 5.2, and pages 192 to 193 if you want to go back and see what they have to say. So we're going to start off with a definition. Obviously, pause the video at any point if you need to slow down or if you need to go back to write down anything. So the first thing we need to do is define what a ratio is. So a ratio, I'm going to underline that word because it's really important. A ratio is a comparison between two quantities. And ratios can be written part to part, part to whole, or whole to part comparison. So you can compare a part of something to another part of something to all of the thing, or all of the thing to part of something. Those are the different comparisons. We write ratios so ratios can be written using the words. So you can either use the words there are blank for every blank. So you would fill in those blanks. So there are 6 dogs for every 12 cats. Okay? So you can use it in the words. You can use a colon. So you could do like 6:7. And so for here it'd be like 6 cats for every 7 dogs. You fill in those blanks. Using the colon, you just put the colon in between. Or you can use the word two. So that would be like 6 to 7. So those are the 3 ways that we can write ratios. We can also write them as a fraction. So like 6/7. So let's do an example. For this example, I'm going to use my highlighters. And you can use crayons, you can use highlighters, you can use markers, whatever you have. I just happen to have crayon or some highlighters right here. And I'm going to do 3 lines with yellow. And I'm going to do 4 lines with pink. All right? So that is my information I'm going to use, my data. Okay? So the first one, I could do part to part. And I could say, there are 3 yellow lines for every 4 pink lines. Notice I'm using the phrase, there are for every, and then I'm just plugging in my data. Okay. We could also write the colon, 3 to 4, or use 3 to 4, or 3 over 4. We could also do part to whole. This could also be reversed to whole to part, depending on how you want to represent your data. Okay, so in this case, if I did part to whole, I would say there are 3 yellow lines for every 1, 2, 3, 4, 5, 6, 7 total lines. So there could be a pattern here. So if I kept going and I kept drawing, I would do, after these 4, I would do another 3 yellow, then I do another 4 pink, another 3 yellow. So every time I have 7 lines, 3 of them are going to be yellow. So again, we use those phrases. Now with this, we would have colon 3 to 7, or 3 to 7, or 3 over 7. Any of those would work. And you could reverse it. So we could do a whole to part where we would say, okay, we have 7 total lines. There are 7 total lines for every 3 yellow lines. So you can flip it as well. All right, so we're going to turn the page a little bit and move from just a brief explanation of what a ratio is to now we're going to talk about equivalent ratios. So 2 ratios that describe the same relationship are equivalent ratios. Now, I hope you guys remember that word equivalent and how equivalent is a word that we use when we're talking in math about something that has the same value, the same. So, for example, you could have like 1 to 2 would be equivalent to 2 to 4. Think about our equivalent fractions. Wouldn't 1/2 be equivalent to 2/4? They have the same value. They're just written in a different way, but they are the same value. So it's the same thing. You can find equivalent ratios by doing a couple different things. One, you can use adding or subtracting. In the equivalent ratios. I'll show you what that means in a second. Or 2, you can multiply or divide. Each quantity and you do that in the ratio by the same number. So like for this one, I could say, okay, 1 plus 1 is 2, 2 plus 2 is 4. So I have a pattern. 1 plus, so if I did then 2 plus 1, I would have 3. 4 plus 2 is 6. So you just keep doing those patterns of adding the same numbers to both the top and bottom. So If you add 1 to the top, you always add 1 to the top. If you add 2 to the bottom, you always add 2 to the bottom. And a table really makes it easier for us to see that. Or you can multiply and divide by the same number. So in this case, I multiplied both the top and the bottom by 2. So 1 times 2 is 2. 2 times 2 is 4. To keep going, I would do 2 times 2 is 4. 4 times 2 is 8. And I could keep going. So we're going to show you how this is best organized in the table. To do that, I'm actually going to turn the page. Actually, I went backwards, the previous page back. And I'm going to create a table. So we organize ratios in a table. So find the missing values in the ratio table. And that's what we're going to call this thing that we're going to make, okay? So I'm going to start off by creating a table. Simple table. Basically, it's just a box. Then I'm going to divide. There's my table. Okay. Now, let's say I'm comparing pencils, how many pencils I have to how many pens I have. You know, a single has lots of pens and pencils. So let's say for every 1 pencil I have 3 pens. It's probably true. I use a lot of pens because they show up better. Now, it gives me also, I know I have 2 pencils, but I need to figure out how many pens I have. So here's what you're going to do. If you're using addition, we're going to figure out what we do to get from here to here. So on the top, I'm going to add 1. So to get from here to here, I add 1, which means I just keep doing that. So 2 plus 1 is 3. Now the bottom and the top are separate in here. So we keep on this top one, we add 1. Now on the bottom, we have to figure out what we do. Now for that, we're going to skip. We're going to skip from here to here. Okay? So to do that, I know if I have to get to 9, but I'm going to skip a spot, what do I do to 3 to get to 9? Well, I would do 3 plus 3 plus 3, right? So that tells me if I add 3, I can get this number because 3 plus 3 plus another 3 will equal my 9. So let's do that. So add 3. Well, what is 3 plus 3? 6. All right. Add another 3, and then we get to our 9 where we need it to be. So for this row, we're going to add 3. Now, addition can be a little bit confusing because we are not doing the same thing to the top and the bottom. We have different numbers we're adding to the top and different numbers we're adding to the bottom. If I were to just add 1 to the bottom, I wouldn't get where I need to be because 3 plus 1 would be 4. 4 plus 1 would be 5. I wouldn't get to that 9, which is where I need to get. So you do have to do a little mystery work in here, problem solving to figure out what numbers you're adding. But if I continue this table, I can keep adding 3. And my next one would be 9 plus 3 would be 12. 3 plus 1 would be 4. So I would have 4 12s as my next one. That's addition. And you end up with ratios 1 to 3, 2 to 6, 3 to 9. And like I said, we could keep going, add another 1, add another 3, add another 1, add another 3, and you can keep going. Okay? Here are your ratios. So that's one way. using addition. There's another way that I like to do, which is using multiplication. Okay, so with multiplication, I'm going to create another table, just the same way I did before. Okay, now with this one, sorry, a little extra, I'm going to do, let's compare how many dogs are in a pet store to how many cats they have. So let's say they have for every 4 dogs, they have 6 cats. And what would happen with the data if we went to 12 and we went to 24? So 12 cats and 24 dogs. What do we have to do? So with this one, we're going to do multiplication. By the way, just so you know, I did addition here, but I could easily do subtraction too. I could say 2 minus 1 is 1. 9 minus 3 is 6. 6 minus 3 is 3. So you can go the reverse way and do subtraction as well. Just like with this, I could do multiplication if I'm going this way, but if I'm going to go backwards, I could do division. And sometimes division actually helps us to solve it. So for this one, I need to ask myself, what do I do to 6 to get to 12? Well, I times it by 2. Now, with that, when you do multiplication or division, you do both the top and the bottom the same. So while I did addition, I had a different number on the top and the bottom. When I do multiplication, I have the same one on the top and the bottom, which makes it really simple. So I actually prefer doing multiplication. So I know I can do 6 times 2 equals 12. 12 times 2 equals 24. Or I'm sorry. Actually, oops, I made a mistake. Hold on, we have a problem here. And I will tell you why. Ms. Engel went too quickly. When you do multiplication tables, it's not the same here. So see here we did plus 3, plus 3, plus 3. This is going to change. Every ratio on the table could have a different multiplication. As long as we're doing these ones together, so whatever you did to these two in this relationship, you're going to do the same here. So this will be also times 2. So 4 times 2 is 8. Okay, that one is done. Now here's where we get to the problem. 8 goes into 24. Well, 8 does not go into 24 2 times, does it? No. 8 goes into 24 3 times. So the second one is going to be times 3. Okay? Notice that when we're doing this, each set of 2 boxes has its own multiplier. Okay? So this set of 2 boxes was multiplied by 2. But this set of 2 boxes is multiplied by 3. So don't do what Miss Engel did and just rush through and think, oh, I've got my answer. I'm going to just keep going all the way across because it might not be true. And you have to double check. Does your answer make sense? When I looked at that 24, I said, oh, 24, 24, that doesn't make sense. So then I went back and I said, oh, I see what I did. 12 times 3 is 36. So in this case, our relationship would be, we have 4 over 6, 8 over 12, and then 24 over 36. Now, here's the thing, guys. It doesn't give us missing or fill in the blank terms after this. So we could double it, we could triple it, but as long as we do it the same to the top and the bottom, you're going to be fine. So I could say, okay, my next one is going to be 24 times 2, which is 48, over 36 times 2, which is 72. As long as I did the same thing and I multiplied times 2, it's fine. But if you have those fill in the blank numbers, you have to find the relationship. What do you do to this number to get to this number? And remember, you're only looking at sets of 2. So what do you do to this to get to that? And that's the difference between multiplying and dividing. So let's do one last one. Let's do boys to girls. Okay, so let's say I have for every 3 boys, I have 5 girls. And for this one, I'm going to fill in my terms. So let's say I have 9 and I have 20. Okay. All right. Actually, let's do 30. All right. All right, so let's fill in our blanks. We're going to use the multiplication method. So how many times does 3 go into 9? Well, 3 times 3 equals 9, right? So 5 times 3 equals 15. Notice I'm looking just at this relationship. All right? Now, let's do the next one. Looking at the next box, what do I do to 15 to get to 30? Well, I multiply it by 2. So whatever you do down there, you gotta do up here. 9 times 2, 18. And that's your ratio. Now, if I was adding, there would be some spots missing in here. So if I was adding, I would have 3 over 5. And let's say every time I add 3 to the top, so I could have 6, 9, 12, 15, 18. And every time to the bottom, I'm going to add 5. So I would have 5, 10, 15, 20, 25, 30. I get to the same ratios, guys, but I did them different ways. On this one, I would add 5 to each one and add 3 to each one. That was the addition method. Up here, I just figured out what is the relationship between these two numbers that are sitting right next to each other. With the addition method, I had to write out more of a table because I had to include every term that was in between. With the multiplication model, I can skip and make it a little quicker. So it's up to you what you like to do, but both methods work. Just remember, with the key to this is when you're doing addition, whatever you do to the top, you consistently do all the way across. Whatever you do to the bottom, you consistently do all the way across. If you're doing multiplication, you only look at sets of 2. You know, I can look here even and say, okay, what's happening for 3 to get to 18? Well, I'm multiplying by 6. If I multiply by 6 to get to that at the top, I can do the same to the bottom. 5 times 6 is 30. But you're always comparing just 2 boxes. All right? Go back and rewatch the video if you need help. Come to intervention. Also, if you have questions. I hope you guys have a great day, and I will talk to you soon. Bye.